All right, this video goes along with the SOHCAHTOA notes on solving right triangles, okay? Solving right triangles just means we're going to find the missing parts. So you're going to be given at least 3 values. You're going to be given the right angle because you have to know it's a right triangle that you're dealing with. And you're going to be given 2 other parts. Okay, in this example, we're given angle A is 63 degrees. And this side, which we can call side A or side BC here, has a length of 15. So the 3 parts that are missing are angle B, okay, this hypotenuse AB, which we can call side C because it's opposite angle C, and this side AC, which we can also call side B because it's opposite angle B, okay. Doesn't really matter what order you go in to find those 3. The math that you're going to use to find those 3 is different, okay, and I suggest starting with the easiest one, which in this case will be angle B, all right. One thing before we get started, okay, up here in all caps, do not use values that you find to find other values, okay? What that means is, yeah, it's pretty easy to find angle B, but you might make a calculation error and say angle B is 37 degrees, for example. We know that's not the case, but it's a pretty common mistake. If you use that 37 degrees in subsequent calculations to find these other sides, you're using wrong information, okay? So we always want to stick with the given information in our calculations to find what's missing, all right? So the first thing we want to do is we want to find angle B, okay? We know that the 2 acute angles in a right triangle sum to 90. They're complementary, okay? Therefore, we know angle B is 27 degrees, not 37 degrees, which would be a number that some people might get mistakenly, all right? So angle B is 27 degrees. Now we're going to use trig functions, those trig ratios we just learned, sine, cosine, and tangent, to find the missing side lengths, okay? So we're going to start out by finding this hypotenuse, side C. And we're going to have to use sine to do that, okay? The sine of 63 degrees equals the opposite 15 over the hypotenuse C, okay? We know how to solve that now. We're going to multiply both sides by C, and then we've got to divide both sides by sine of 63. Let me scroll down so that we've got enough there to solve for side C. So the hypotenuse in this problem should be approximately 16.83 degrees. You'll use your scientific calculator to find that value, okay? So we know side C is 16.83, all right? Next thing we want to do is find side B, okay? So we're going to use trig functions to find side B. We're going to use the tangent of 63, okay? So the tangent of 63 equals the opposite 15 over the adjacent, which we'll call B in this case. We're going to multiply both sides by B. We're going to divide both sides by tan 63, and that's going to give us our missing side length, which is approximately 7.64. Okay. So we found all 3 missing parts. Now we know all 6 parts to this triangle, so we've solved the right triangle. Okay. Let's move on down to problem number 2 here. Okay. In this case, we know we're dealing with a right triangle, but this time we're given 2 sides, okay? We're not given either of the 2 acute angles. We're given the 2 side lengths, okay? So we're going to need to find both those angles, angles A and B, and we're going to have to find the hypotenuse. We can call that AB, or we can call it side C, all right? So the first thing we need to do here is we're going to use Pythagorean theorem to find the measure of AB. Now, hopefully you recognize this as a Pythagorean triple, that 5, 12, 13 triple. But if you don't, you can use the Pythagorean theorem. Eventually we'll get to c squared equals 169, and that gives us the hypotenuse having a length of 13. Okay, so side C equals 13. So now on to find the missing angles, okay? We need to find angles A and B, and I'm going to use trig functions and then inverse trig functions because we're solving for angle measure, okay? So the first one I want to find is angle A. All right, so angle A is this angle right here. We're going to use tangent. We don't know the hypotenuse officially, remember, because we're not using any values we calculated. So we're just going to use the 5 and the 12. So the tangent of angle A would be 5 over 12. Okay, so remember from last lesson, we're going to do inverse trig functions. So inverse tan in this case of 5/12 is going to be angle A. And when we use our calculator, that's going to give us an approximate angle measure of 22.62. Okay, so angle A is 22.62. Last thing to do is to find angle B. We're going to use tangent again, but the ratio is going to be flipped because we're starting in a different place. We're starting with angle B here. Okay, so angle B, the tangent opposite would be 12 over adjacent, which would be 5. Use inverse tan of that ratio to find angle B, and that gives us an approximate value of 67.38. All right, so now we've solved this right triangle. We found the two missing angle measures. They should add to be 90 degrees, and they do. Okay, and then we found the hypotenuse to be 13. So we've completed that one. Thank you.